Alright, hey guys, we're going to do lesson 12.1, and it's talking about reflections. So remember we talked about transformation on Friday as a one-to-one relationship that changes a figure, changes its location, changes its direction, changes its side, that we do in geometry. So we had a couple rules that we remembered. Like for instance, if this was my original image, like ABC, and I would do a translation to it, we know that we'd have our other figure would be A prime, B prime, C prime. We know that we transform to it. And this one, again, just make sure we're on the same thing. This is your pre-image, is the one you start with. And then you have your image is the one that you end with. So we're actually going to skip down and put that in our fill in the blank. So the image is what you end with. And the pre-image, and I'll read this a little bit later to make sense, is where you started. So let's keep that type of terminology in mind. And also remember, I used this word with you, but I did not have you write down on Friday. It's called an isometry. An isometry is a transformation that preserves size and shape. So remember, when we were going through the 4 different types of transformations, we had reflections, translations, and rotations. Those were considered isometries. Dilations, which enlarged or reduced a figure, are not an isometry because they don't preserve size and shape. So there's a couple different ways that they call these. These call these congruence transformations is another way of talking about it. You know, you wish mathematicians could get everything the same, right? Or they're called rigid motions, like things don't change. It's very rigid, the rules. So that kind of makes sense on those. Again, so we just talk about recall. It moves a figure, the pre-image flipping it across the line. So a reflection, what is it? A reflection is a transformation that moves a figure by flipping it across a given line. The reflected image is called the image, and the original one is called the pre-image. So if you remember, I was letting you guys play with this thing called a mirror. And if you remember, we could reflect it over. And you know, it's like here, I could reflect, you can see the reflection of this figure onto the other. However, if you notice, it doesn't really reflect it correctly. It doesn't get the same thing. So we knew it totally flipped it over. So on this first one, is this one going to be a reflection? And it says we're supposed to explain. So guys, you have to use words to explain why this doesn't work. So no, it's not a reflection because look at it, it just moves. It didn't flip it over the line. So if that's the case, no, it is a translation, or it appears to be a translation, not flipped. Now if you look at this one here, if I look at my reflection of it, do you guys see the reflection in the mirror right there? You can see how it reflects across. Notice it's exactly the same size and shape. It looks like it flipped. It looked like it flipped right over this line right here in the middle of it. So the cool thing is, let's put that down. Yes. Each point of the pre-image was reflected across. Across a line. So you can see that literally it flipped. Now remember, if you need to review basic transformations, just go back to what we talked about so you can describe these a little bit better on Friday. Or the day that we did identifying transformations worksheet and stuff that we're working with it. Okay, so on this one, I need to do the same thing. Are there reflections or not? Now, when I look at this, can I draw a line in the middle and does it flip perfectly over? No. It appears to me, it almost looks like it was rotated. Like if I have a point here, I could rotate that one across, you know, maybe even a little bit further down and rotate the figure, but it's definitely not flipped over. So no, not flipped over the line. Now here, if you look at the figure, you can really see how it is reflected across. You can see the flip, because when I move this, like, whew, yeah, it's been flipped over. So yes, it was flipped over the line. Very, I know, complicated. All right, now let's use a couple other ones. Now let's talk about this. when we're doing this, you have to kind of understand what's being done. So we're going to actually do this real quickly. I don't expect you guys to be perfect on this, but I want you to draw a segment from each vertex of the pre-image to the corresponding vertex of the image. So let this one be our pre-image, and this will be our image. What I mean by that is, like, you could see that these two are going to correspond. These two would have to correspond. Let's pick one other spot on our shape to correspond going across. Okay? Then, you said your construction should show the line of reflection is the perpendicular bisector. Here's what I mean by this. Notice I have these 3 line segments. If I have a line of reflection, it needs to go smack dab in the middle. Remember, we talked about this on last Friday. It has to be the perpendicular bisector because it has to be the same distance away for every one of these. So it has to go through. And that line is called the line of reflection. So I want to draw an arrow across to it. Now, let's fill in the information. So reflection is a transformation called across a line called the line of reflection. It's very similar to like the line of symmetry. So that the line of reflection is the perpendicular bisector of each segment joining each point in its image. So let me give you an example of what I mean by this. We need to be able to do this even with out a mirror, because I mean, obviously, let me show you how easy this would be. If I have a mirror, I put it on here, and the image would reflect across, and if I can get my face down here, I could reflect across, mark the vertices, and go. But when I don't have that, I have to figure out a way of working with this. So what you want to do is you're going to draw a line across that is going to be perpendicular, and you can freehand it just for the moment, to my line of reflection. And I'm going to go to every vertex because it keeps it easier this way. I'm just going to draw a line a little bit further through. Do the same type of idea here. Now, remember, the line of reflection has to be the perpendicular bisector. So I need these all to be right angles, but then I'm going to do a quick measurement between each vertex. Like, I'm just going to call this one A, B, C. And I'm going to do A, its prime. So I know I need to go from here to here distance-wise, because the distance has to be the same. So there's A prime. And then I'm going to do the same idea with B, its distance across. I go over here. I can eyeball it and get B prime. And then C, it's a lot closer here, you C prime. So when you're doing that, I just connect them. Here we go. All the way through. And then you can see your image. Works out pretty cool. All right, now let's go. And there's one more we could do this with. And you do the same type of idea. Now, I'm not going to have you guys do this right now in your notes. But again, you would just draw a segment going straight across that's perpendicular. And you do this for every one of your vertices because those are the easiest ones to do. You would go ahead and measure it across. So I make sure I have my right angles. I'd measure the distances across from here to here, and I reflect it over. And then you'd have the same type of idea. Does that make sense? Yeah, so it's a kind of an easy way of working with it. And then you'd have each one of your primes. So we're not going to go further than that on here just because it takes a lot of time. But if you want to remember how to do it, remember, mark your distance from your line of reflection to your vertex. Then you go straight across on that line. And then there would be your prime. So like if that was A, that would be A prime. You just do it across for the whole thing. Actually, why don't I go ahead and finish that real quick. I wasn't going to do it, but now I am. It's a lot more fun. So we go here, measuring it. I'm going to use simply a ruler at the edge of my note card. That be B. This will be B prime. C is going to be a lot closer. C prime. And over here we're going to go D. D prime. So just matching them up. I'm going to just do a quick reference to all of these. I didn't draw a very good line here earlier, but the idea of it being reflected across, wow, horribly unstraight line segment driving me nuts. All right, and then we're going to talk about very specific mappings and arrow notations to show with this.